All right, on page 11, number 73, we have a random sample of 500 Army recruits that has a mean height of 68 inches with a standard deviation of 2.5 inches. Assuming all the conditions have been met, what's the margin of error for the 95% confidence interval? So personally, what I did with this one is I didn't use the margin of error formula. I just found the confidence interval. So remember, to get to that confidence interval, you hit stat and then arrow over to test. And it's going to be a t interval because we're doing means now, which are t-scores. And it's an interval that you're trying to calculate. We still have the stats, just like the previous problem. The mean height is 68, standard deviation of 2.5 with a sample size of 500. And we're calculating it at the 95% confidence level. So I'm going to type in 0.95 and hit calculate. So once I find that confidence interval, I get 67.78, 68.22. And then you can easily find the margin of error from there. There's a couple different ways you could do this. Okay, you could find the point estimate, which is X bar, which you technically already know is 68, right in the middle. And then just find the distance in between. That's probably the best way to go about this, honestly, is because you already know X bar is 68. So if I just do 68.22 minus 68, that's how I get a margin of error of 0.22. So that'd be letter C. Okay, number 74. A snack food maker claims that the weight of its new packages is 48 ounces. An agent from the Food and Drug Administration believes that the packages hold less than the stated amount. So we're going to let mu be the true mean weight in ounces of all packages produced by the company. And which of the following represents the null and alternative hypotheses the investigator should test? So now we're getting into hypothesis testing with means. Remember that the null, you first of all have to assume that the population mean, so I can get rid of D because that's sample mean, is equal to. So just by knowing what the null has to look like alone, this has to be letter A. Okay, that's because the mean has to be, in the null hypothesis, the population mean has to be equal to the claimed value. And then your alternative is what they're trying to gather evidence for, which is less than the stated amount. But once again, just by looking at the null hypothesis alone, it has to be letter A. Number 75. A state property value appraiser claims that the mean land value in a city is $85,000 per acre. A building contractor runs a check on a sample of 10 recent sales and notes the average sale was 79,000, so that's our mean, with a standard deviation of 9,000. So what's the test statistic? Remember, with hypothesis testing with means, the test statistic is not a z-score, it's the t-score. Okay, you guys have to remember that means do change things. They give us the two hypotheses, a null hypothesis of 85,000, an alternative that it's not 85,000. So now, instead of calculating a confidence interval for t-scores, I'm going to go to stat test, and I want to do a t-test. Okay, so a t-test is a t-score hypothesis test. Number 2. We have the stats, we don't have data. So the claimed null hypothesis value is 85,000. The average sale was 79,000 with a standard deviation of 9,000. The sample size, they took that from, they do give a sample size. Took me way too long to see that. So the sample size is going to be a t-test of a sample size of 10. And once again, the alternative hypothesis is not equal to. So the t-score that they gave us after I wasted way too much time with that is a negative 2.108. So now that I found that, let's keep going. On number 76, in testing the null hypothesis of mu equal to 0.75 against the alternative hypothesis of mu is greater than 0.75, a sample from a normal population has a mean of 7.69 with a corresponding t-score of 2.23 and a p-value of 0.0175. So which of the following are a reasonable conclusion given that we're testing at our level of significance of 0.05? So they've pretty much done all the work for us here. We just have to compare the p-value to alpha and talk about our conclusion. So my p-value of 0.0175, so my p-value is less than or equal to my level of significance of 0.05. So remember that if it's less than if it's less than or equal to alpha, that means you can reject HO, and it also means that you have sufficient evidence for HA. Sufficient evidence for HA. So let's see which one falls into this. So 76. Number 1 says, if the null hypothesis is assumed to be true, the probability of attaining a sample mean as extreme or more extreme as 7.69 is 0.0175. That is true. That's kind of the definition of a p-value. So if you guys look back in your notes, a p-value is the probability of obtaining that sample value as extreme or more extreme. So the probability is your p-value. Okay. The potential error for this hypothesis is a type 1 error. Remember, if you have sufficient evidence, that could be a type 1 error. So that's true. And then there's insufficient evidence to reject the null hypothesis. That's not true, right? We have sufficient evidence. It's got to be 1 and 2 only. All right, 77. You are thinking of using a T procedure to test the hypothesized mean of a population. You suspect that the distribution of the population is not normal and may be moderately skewed. So which of the following statements is correct? So the conditions are not met because the population does not have a normal distribution. So let's see. We are doing a test procedure for a hypothesis mean of a population. Okay. So we don't really have enough evidence to say that it's not approximately normal. There's nothing that gives that away. So let's see what the next one says. The conditions will be met provided your sample size is at least 30. Remember, if you are able to get a sample size of greater than or equal to 30, we can say approximately normal. We just don't know that yet because we don't have enough information in this problem. But if your sample size is at least 30, the conditions will be met. Okay, let's see. The conditions are met because the box plots will show outliers. That's definitely not true. Okay, if your box plot shows outliers, then it's not approximately symmetrical, which means it's not approximately normal. So that's definitely out. And then the conditions will be met provided that your sample size is less than 30. That's not true. It has to be greater than or equal to 30. So since A does not have enough evidence to say we don't have a normal distribution, the correct answer there would be letter B. Let's see where we're at on time. Okay. So we will pick up with page 12, number 78 in the next video, just to make sure we're doing okay on time and I don't get cut off because I've been doing kind of bad at that lately. So see you in the next video.